So for this lit review, I did visual chunking representation accommodation. I found this intervention in the article titled The Effect of Visual Chunking Representation Accommodation on Geometry Testing for Students with Disabilities. This article was written by and the study was conducted by Date Zhang, Yi Ding, Joanna Stegall, and Lei Mo. So why is this study important, and why did researchers believe it was important before they even began? So the research says that geometry is a really important part of life for students nowadays. Geometry is becoming important in all parts of math and future learning, and as well as just everyday life, what they're going to need when they get out of school. In fact, Common Core state standards have called for an increased geometry instruction due to how far behind we are compared to the other states. Not the other states, the other countries, I'm sorry. We are so far behind the other countries in geometry instruction that the government has said, hey, we need to increase the instruction in geometry. So with this increase of instruction in geometry, we're going to see more students struggling with geometry. These struggles can be due to difficulties comprehending problems, visual spatial deficits, deficits in cognitive ability, and difficulties with working memory. This intervention that we're going to be talking about right now really focuses on difficulties with visual spatial deficits or difficulties with working memory. In fact, your visual working memory is what it really focuses on. Your visual working memory holds and manipulates images, which helps you learn and use geometry. And in fact, research has proven that if you can decrease cognitive load, so decrease how much you're going to have to remember or how much is going to be in your visual working memory, then the intervention will actually be more effective. Visual chunking representation actually does this and allows for a person to retain more information in a less complex way. So visual chunking representation allows for a person to retain 4 objects, 4 features, and 4 single feature objects instead of just our standard small amounts. But when they're in our working memory, it's not as big of a load because they're all connected. So the purpose of this study. The purpose of this study was not explicitly stated in the text. It did not specifically state the purpose of this study is blank. But this is the purpose of the study listed in a different way. It says this study investigated the effects of visual chunking representation as a testing accommodation for improving students' geometry problem-solving performance. Visual chunking representation is actually just an intervention. For this study, they took it and they manipulated it actually into a testing accommodation to see if it improved test scores for students who struggled with geometry performance. So what is visual chunking representation? Visual chunking representation is a process of organizing patterns of thought to allow for a person to remember more. So if you look down into the picture in the lower right hand corner, you can see the main topic as the sequence. The sequence is broken down into chunks, and the chunks are broken down into different elements. Without the visual chunking representation accommodation, we may not be able to remember all of this. We may just be able to remember the sequence and 1 or 2 of the chunks. But when we break them down into smaller versions and connect them to each other, it works as a visual chunk that represents a lot of knowledge and allows for students to remember more. In fact, using the visual chunking representation, people can remember 4 objects with 4 features and 4 single feature objects instead of the regular 10 or so digits. We're taught in a lot of our education courses that we can only remember so much, like the length of our phone number, and that is why our phone number is the length it is. So this accommodation and intervention lets you remember more in a more consolidated format. So students are taught to view the shape and or the materials as chunks of information instead of individual pieces. So these chunks of information can be manipulated instead of just those individual pieces that are concrete facts. So, how did they test this study? Or how did they test this intervention? They began with 4 students who struggled with the results of the study. All participants performed better with the VCR accommodation, and it was not just a small percent better, they really excelled with the accommodation. So the next 2 points show the scores before and after the accommodation. So without the accommodation, the first student scored a 39.375% correct, but with the accommodation, the same student scored a 73.13% correct. Without the accommodation, the second student scored a 50% correct, and with the accommodation, that same student scored an 82.188% correct. The third student, without the accommodation, scored a 42.815% correct, but with the accommodation, scored a 79.375% correct. And the last student scored a 53.44% correct without the accommodation and 77.188% correct with the accommodation. So all participants, in fact, stated at the end of the testing that they enjoyed the VCR accommodation and condition better than standard testing. This was not a burden that the students had to carry. It was not an accommodation that made testing more strenuous or longer. Students actually enjoyed using the accommodation better than they did testing normally. And in fact, 3 out of the 4 participants said the VCR accommodation made the test material easier for them to understand. And why is this important to us? This study helps to clarify what visual chunking representation is and how we can use it in a classroom to help students with and without disabilities. It breaks down the process of VCR and how to teach it, as well as how it could be used in the classroom. It also helps us understand how to instruct different students using the same accommodation. We're well aware that students have varying needs and abilities, so this accommodation has been proven to help a wide range of students that did not have just one specific label. It was able to help all students. So it's worth a shot if you have a lot of students who have some form of a math disability or falling a little behind in math or geometry, to try this and help all your students instead of trying to find these individual interventions that will strain your focus. This study also helps teachers understand a way to help students who are struggling with geometry perform closer to grade level. So these students previously had been scoring at failing level when given the probes. They were scoring well below a C, but with the accommodation, they were able to score at high CB level. This study also provides an evidence-based practice. So we're in charge of providing evidence-based practices by law. So this one study provides an evidence-based practice that's proven to help students. So it's one thing to put in your toolbox so that you have something that is evidence-based to help students when they struggle. Teachers can also use the VCR accommodation in their own classrooms by implementing this into teaching strategies, activities, and tests. So instead of just putting it with tests, we can stretch it and do activities and different teaching strategies with it. However, you need to become aware that it is going to need some instruction. You are going to have to teach your students how to use VCR and how to manipulate items using their brain like that. So be prepared to provide some instruction on that beforehand using some modeling and other techniques. So my last slide, I provided the APA citation, just with the author's name and the title, as well as the link where I got my information from on Southern's library database. All right, so thank you. Math in a Midwestern United States elementary school. These students had to be recommended by their teacher before they were able to participate in the study. These students also scored at average or below average on an IQ test, lower than the 35th percentile on the Woodcock-Johnson test of achievement in math fluency, and 3 of the students scored 40% on the state standard test in mathematics, and 1 student did not pass at all. We typically won't think of 40% as passing, but in the article it did state that 40%, or they scored 40%, and then 1 student did not pass at all. All sessions of the study were conducted in an empty, quiet teacher meeting room at the students' school. The students weren't removed from their ordinary environment. They were just put in a different section of their school. So, in order to test, they gave each student 8 geometry probes, and the probes either had the BCR accommodation or did not. However, all students received probes with and without the accommodation. So there was no control group. There were some students receiving no accommodations and some students receiving accommodations. They all received tests with and without the accommodation. Each probe asked the students to imagine manipulating a shape and choose the shape that could be formed by that manipulation. So, for example, it might ask the student to imagine manipulating a square and choose what square could be formed by that manipulation. So, for an example, if you imagine a square can be manipulated into a triangle, and that would be your answer. Each test was given individually. No students were tested in a classroom setting. It was just 1 teacher and 1 student at a time. Each testing session lasted about 5 to 10 minutes, and they were given 4 probes a day. There were 2 to 3 days between each test. The whole testing period and all 8 probes lasted about 2 weeks, so they had plenty of time in between tests to calm down and not feel overwhelmed. And also, the experimenter read the questions and provided student examples until they understood what was being asked of them, so that there were no barriers due to reading or reading comprehension or comprehension of what was being asked.